Hey guys, this is your Madam Vash and welcome to my channel.
In this video, I'll be showing how to balance a redox equation using the ion-electron method and work on a possible calculation that might be asked next. Let's look into the question. Here, we have a 25 ml solution containing C2O4 ions that was titrated with KMnO4 solution in an acidic medium. The C2O4 ions were oxidized to carbon dioxide, whereas the MnO4 ions from the KMnO4 was reduced to Mn2 ions. And if 30.5 ml of 1.25 molar of the KMnO4 solution is required for the titration, you are supposed to write a balance equation for this titration as well as calculate the concentration of the solution containing the C2O4 ion. So as you can see, this question has got two parts, and let's attempt the first part, which is to write a balance equation for the titration. So in order to write a balance equation, first you are required to divide and balance the half equations for the oxidation and reduction process. So let's do that. For oxidation, it would be the conversion of C2O4 ion into carbon dioxide. This is given in the question. So as you can see, in order to balance an half equation, first you have to balance the number of atoms before and after. Before the reaction, there is 2 carbon atoms. Therefore, after the reaction, it's supposed to be 2 carbon atoms as well. However, we only have 1. Therefore, multiply carbon dioxide by a factor of 2. By doing this, the number of carbon atoms are now balanced. And let's look at the oxygen atoms before and after. We have 4 oxygen atoms before. Since we have done a multiplication to carbon dioxide, the oxygen atoms are also 4 after the reaction. So the atoms are happy. Now let's look at the charges. The next thing that you have to do to balance half equation would be to balance the charges. Before reaction, the total charge on the left hand side is -2, and after reaction, as you can see, since carbon dioxide is neutral, the total charge is 0. So in order to balance the charges, you are required to add 2 electrons on the right hand side. By doing this, the charges before and after reaction is now -2. Next, let's do it for reduction. So here we can see that the MnO4 ions are converted into Mn2 ions. Firstly, balance the number of atoms. We have 1 Mn on the left and 1 Mn on the right. However, there is 4 oxygen atoms on the left and none on the right. Therefore, in order to introduce oxygen into a system, we should use water. Nothing else here, only water. So we have 4 oxygen atoms. Therefore, we require 4 water molecules. Since 1 water molecule only supplies 1 oxygen atom, therefore we need 4 water molecules. By introducing water to the system, we have also introduced another atom, which is hydrogen. Thus, you can see on the left hand side, there is no hydrogen atoms. So, add H ions to introduce hydrogen atoms to the system. And how many do we require? We require 8. By doing this, you can see that the number of atoms before and after the reaction has been balanced. However, the charges are not balanced. Therefore, the charges before reaction would be -1 plus +8, giving a total charge of +7 on the left, and on the right, there is a total charge of +2. Therefore, in order to balance the charges, 5 electrons must be added before reaction. In order to produce a balanced redox equation, we are required to combine the oxidation and reduction equation. So let's do that. It would be C2O4 2- producing 2 carbon dioxide. with 2 electrons. And as for the reduction equation, it would be MnO4 minus plus 8H plus 5 electron to produce Mn2 plus and 4 water. Now, in order to combine these two equations, the electrons must be cancelled. How do we do that? As you can see, there is 5 electrons on the reduction equation and 2 electrons for the oxidation equation, and the lowest common multiple of these two numbers would be 10. Therefore, multiply the first equation by 5 and the second equation by 2. By doing this, it would cancel off the electrons on the left and right. So let's write out the complete equation. It would be 5C2O4 2 minus plus 2MnO4 minus plus 16H plus to produce 10CO2 plus 2Mn2 plus 8H2O. Next, try to analyze whether there is any redundancy in the molecules that we have written. Looks like there's none. Therefore, this is your final answer for part A. Next, for part B, we are required to calculate the concentration of C2O4 2 minus ion. So in order to do that, let's calculate the number of moles of KMnO4. The number of moles of KMnO4 would be, using the formula mv over 1000 would give you 1.25 multiplied by 30.5 divided by 1000, and it would be 0.038 mole. Here, do realize that the number of mole of MnO4 minus ions is equivalent to the number of mole of KMnO4, which is 0.038 mole. In order to calculate the concentration of C2O4 2 minus ion, we must relate it with the MnO4 ions. That would be from the balanced equation. As you can see over here, from the balanced equation, 2 moles of MnO4 minus ion reacts with 5 moles of C2O4 ions. So let's write that out. That would be from the balanced equation, 2 mole of MnO4 minus ion reacts with 5 mole of C2O4 2 minus ions. Thus, 0.038 mole of MnO4 minus would react with 5 times 0.038 divided by 2 mole of C2O4 2 minus, and this answer would be 0.095 moles. So in order to find molarity, in other words concentration, we would be using the formula molarity equals to number of moles of C2O4 2 minus ion divided by the volume of the C2O4 2 minus solution. So here it would be 0.095 mole divided by the volume. If you remember reading from the question, it was 25 ml, and since the volume of solution must be in liters, it should be 25 divided by 1000. And the final answer would be 3.80 mole per liters. And there you have it, balancing a redox equation and doing a calculation that might be asked after.
Thank you for watching this video. I'll see you in the next.